Hello guys, this is Daniel. It's a pleasure to complete this introductory series on blockchain programming and Python. So today we are going to conclude this series with a continuation of the video that we did before regarding interacting with our own smart contract. We had this little smart contract here, which, as you remember from the previous video, is a guess the number game. So what this game is about is that whoever creates it has to define a secret number and pay an amount of ETH that remains as a deposit in the contract, and then people can come and use this function play to try to guess the number. If they guess the number correctly, the amount of ETH in the contract goes to their address. But if they fail, if they don't guess it correctly, well, basically they lose the opportunity. And the cost of that opportunity is that they have to pay 1 ETH every time that they call this function. So we have the contract here. In our previous video, we did the deployment of this contract through Python. So we have that one in our local ganache. But right now, what we're going to do is build this function that allows us to interact with this play function in the contract. So let's do it. We are here on Visual Studio and we already created some basic scaffolding. If you have any questions about the details on what this scaffolding does, you can go back to the previous videos. I have gone through this in almost all of them. This is the last one, so I think you shouldn't have a lot of problems with that one. All of the things that we have here are importing the libraries that we need, and we are also loading our local environment variables and then creating our connection to the Ethereum local node provider. Having that, we can just call our Python and try to test if everything is working, and for that we use our are-we-connected function. But first, let's import our module, and it's working fine. Now let's test with are-we-connected, which is our traditional method of testing. So the scaffolding is okay, it works. Now we are going to do the rest of this video, and we are going to dedicate it to interacting with this guess the number contract. So for that, what we need to do is to create a contract object, which is going to be very similar to what we did in the video number 2. It was when we interacted with an ERC20 token, because that was interacting with a smart contract in the Ethereum blockchain. Right now we're going to do something very similar, but we are going to be interacting with an Ethereum contract in our own local environment. So for that, we need the contract ABI. As you remember, we copied the ABI in the previous video when we did the deployment. So the ABI, we have copied it here. And we got that ABI from Remix. We got it from the compilation details on there, not on their API, because this one is not very friendly for programming. We use it. We use the one here that is on the Web3 deploy. We copy this part here, and that's what we copied to our environment variable over here, and that's what we are using. And that, as you remember, we already have it in an environment variable, so we're going to call contract ABI is actually OS environ, and we're going to call that one contract ABI here. So that's it. But if you remember this one, there's something that we have to do first, which is a JSON logs, because this is a string as we copy it in our environment variables file. Now the other one that we need is a contract address, and that let's say that is going to be the same OS environ, and we're going to call it contract address. Let's create here contract address and open the space. And right now we are going to go to Ganache to actually get the contract address of our contract here. So we have it here. Contract address is this one, and we return to Visual Studio to paste that contract address here. So having that in our environment variables file, we give you access to this environment variable over here and assign it to this program variable here, global variable that we have in our contract. Now, and the other thing that we want to check is what is the value of the price that we might get if we get the number correct, right? So we're going to create a function here that's going to be called getBalance, and this function is going to be interacting with one of the functions in the contract. And this is going to be very similar to when we were trying to get the total supply of an ERC20 token. So we are going to do exactly the same. We are going to go to create a contract object here, and we're going to call it Web3 connection ETH contract, and this contract has an address which is equal to contract address, which is the one that we copy from the environment variables above, and we're going to have the other one which is AVI, and it's equal to contract AVI. So we have our contract object. Now, to read from that contract, we are going to create another variable here that we're going to call balance contract, and that balance contract will be equal to Web3 connection from way, because the balance is in way, and we're going to translate it to ETH, and then the value that we're going to get is contract functions get balance, which is actually the name of the function in the contract that provides us the balance, and we are going to do a call. We close it, and then this part is what is getting us the value. This is actually the call to the contract function, but we are going to translate it to Ether. So we have that one there, and then we're going to return a balance contract. And this function will allow us to check the balance of the contract. So let's do something right now. Let's test it. Testing time. So right now, the same thing, we're going to import our module, and right now we are going to call our function get balance, and we get decimal 10. So this function is correct. We are getting the value in ETH that the contract is storing right now. If you are curious on where do we know that that function is the one that we'll have to call, is this function over here that returns the balance of the contract. So we are basically interacting with the functions in the Solidity contract through Python. Let's go back to our development. Now we want to also call the other function, which is play, right? Is the one that allows someone to actually interact with the contract and try to guess the number and get the price. So let's do something here. We're going to get def play, and for that one we are going to pass some parameters. We need the player, we need the player guess of the number, we need the amount of ETH because he has to pay something to actually get this one out, and we need a signature. And this is great. We are going to create then a function that will interact with the contract in this way. So right now let's create a contract object, and this one we are just going to copy from above. That's going to save us time, and it's basically the same contract object that we need. So we get it here. It's exactly the same contract object, and then what is going to be different here is that we are going to do something similar as to when we deploy the contract. We need to call a function inside the contract, which in the case of the deployment was the constructor method. Right now we're going to call this play method, which is a function inside the smart contract, but it's the same thing. We need to create a transaction, and that transaction will go into a function call, and then we're going to sign the function call as a signed transaction, and then we send it to the blockchain. So it's very similar process as when we deploy the contract, and we are going to start doing it by defining the transaction body. So let's start transaction body equals, and we create our dictionary here, and for that one we are going to need nonce, and this is a dictionary, so we go nonce, and we need to get the nonce. We're going to create that function later, and we need a value here, which is the value of that we want to send to the contract, which has to be 1 ETH, but we are going to transform it to way, right? So we are going to do Web3 connection, and here, instead of what we did here in get balance, where we wrote from way because we wanted to get some value from way that was in the blockchain, which was the balance, and transform it to Ether to showcase in our screens. Here is the opposite. We are inputting ETH in our screens, but we want to send it as way. So we are going to say to way, and then we are going to send amount ETH, which is the parameter that we are sending, and we want to send we want to say that that one is in Ether, and we want to transform it to way. So this is the transaction body. Now we need to do the function call, and that function call has to have embedded this transaction body here. So we are going to create, as when we deploy the contract, we call it deployment, right? Right now we're going to do something very similar, but we're going to call it function call, and it's going to be a variable that has contract functions. Here was when we put constructor in the case of the deployment, but here we're calling functions because the contract is already deployed. The function that we're calling is play. So if you notice, it's very similar to what we did here in get balance, contract functions, get balance, contract functions, play. And then we are going to send the parameters that play function requires, which is an address and a guest number, right? So the address is going to be the player address, which we are getting from there in our parameter definition, and the guest number, which is guess. So we pass these two parameters, and then we are going to build transaction, and then this build transaction is going to contain the transaction body. Transaction body. Now that we have the function call, then it's basically the same thing that we did with the deployment. We create something that is called signed transaction, and this signed transaction is equal to Web3 connection, the same ETH account signed transaction, and it's going to contain the transaction and the signature, which is the private key of whoever is calling this function, which is here, over here. So we have that one, and then we go to result. The reason we're restoring this in a result is to be able to retrieve the hash. We have Web3 connection, ETH, send raw transaction, and here basically what we're doing is sending this signed transaction to the blockchain to interact with the contract, and raw transaction, signed transaction, that raw transaction. We have it here, and then this one should return result. We need the nonce for this one, so let's get def get nonce, and this get nonce we are going to build it in the following way. We are going to do a return, and we are going to return Web3 connection that ETH that get transaction count of the, we need a parameter here, ETH address. So let's do transaction count ETH address, and here we have it. So we have the get nonce, and then this one is going to be equal to get nonce of player. Testing time. So let's start. Let's do Python, and we know that we were connected before, so I think what we are going to do is just go directly to import our module, which is working. Let's do get balance to check what is the current balance of the ETH. So that's great. Now let's start playing with it. So let's call the play function OS environ address 2. This is the guy that is going to be playing, and then his guess, let's put it as a false guess right now, as a wrong guess. So we're going to write 5. He has to pay 1 ETH to play, so that's it. He has to pay 1 ETH, and we have to send his signature, which is another OS environ. OS environ, and this one is private key 2. So we have address 2, private key 2, and these values. Let's test. Yeah. So the error here, I'm calling it transaction, but it's not transaction. What we're sending here is function call. So that's it. Let's save, and we will have to exit again. And let's clear our screen. Let's do it again, Python. Let's import. And let's call again with the same parameters that we have. Play address 2, private key 2, 5 is the guess number, and paying 1 ETH. We get the response back, so right now it's working, but let's go to Ganesh to see what is going on. So we have transactions. We have 2 transactions now. We have a contract call here. This is the contract creation that we did before. So contract call, this one goes here, and it was called, and with a value of 1 ETH. And let's check right now what is the balance of the contract, because this was a wrong guess, right? So let's check it out. So let's do get balance. And right now it's 11, right? So this guy lost his money there. So let's do another one. Let's do another guess, and let's guess 8. And everything else remained the same. And we get a hash back. So let's try to get balance again. And right now we have 12. So he's just basically losing all his money trying to get the number, right? If you saw the previous video, you know that the right answer was 7. That's the secret number that we assigned to the contract when we created it. So let's do it. Secret number 7. Get it back. And right now we go to Ganache. And we see all the calls that we did. That one, if you see, is using more gas, and that's because that one actually triggered a payment, triggered more computation in the Ethereum network. The previous ones didn't trigger that payment. Let's check the balances now, and we have the accounts. And as we see, this is the guy that deployed the contract, so he had 10 ETH less than the others. And this is the guy that got the jackpot. It has the 10 ETH that this guy put into the contract when everything started. So thank you very much, guys. This has been a little demonstration on how to interact with your own smart contracts through Python, and hope that you have liked the entire series. We are going to come up with more material regarding blockchain, regarding programming in blockchain through Python. Thank you very much for joining. Please follow the series and subscribe to the channel and smash that like. Thank you very much. This is Daniel. Until the next series.